In these problems, we're working on finding the derivatives of some functions that have trig functions in them and are either products or quotients. So we're going to need to know our trig derivatives, and we're going to need to use the product rule or the quotient rule. And so a quick review on the trig derivatives. The derivative of sine of x is cosine x. And the derivative of cosine x is negative sine x. I think that's all you'll need to know for this set of problems. Let's try this first one. Here the function is 3x plus 3 times cosine of x. This is a product, so we're going to use the product rule. And the product rule says you take the first thing times the derivative of the second thing, and then you add that to the derivative of the first thing times the second thing. So let's try that. The first thing is 3x plus 3. The derivative of the second thing, the derivative of cosine of x, is negative sine x. And then we add to that the derivative of this first thing, 3x plus 3, the derivative there is just 3 times the last thing, which is cosine x. So we can multiply through this negative sine x. We'd get negative 3x sine x minus 3 sine x plus 3 cosine x. And maybe that's how we can write the answer. If you want to factor out a 3, you could do that. But this would be an acceptable answer for the derivative. This is f prime of x. All right, let's try another one. This one is pretty similar, except it has a sine in it rather than a cosine. So let's take the first thing, that's 4x minus 2, times the derivative of the second thing. Derivative of sine x is cosine x, plus the derivative of this first thing, 4x minus 2, the derivative of that is just 4, times the second thing, which is sine x. And we'll multiply our cosine through here. We get 4x cosine x minus 2 cosine x plus 4 sine x. And that's our f prime of x. All right, let's try one more. So in this next one we have a quotient. So we're going to be applying the quotient rule, which I remember as low d high minus high d low all over low squared. But before we do that, it looks like we can simplify this fraction. I can take a 2 out of the top and a 2 out of the bottom, so I think I'm going to do that to start with. So this would become 3 sine x over 1 minus 2 cosine x. Might as well make it simpler right off the bat. Now, I'm going to start applying the quotient rule. I've got low, that's 1 minus 2 cosine x, times d high. Well, the derivative of sine x is cosine x, and my constant is 3, so that's just multiplied on. So this is 3 cosine x, minus high, that's 3 sine x, d low. And the derivative of what's on the bottom here, well, the 1 disappears. The derivative of cosine x is negative sine x, and then I've got a negative 2 as a constant. So the negative signs cancel out, and I get 2 sine x. And all of that is over low squared. So 1 minus 2 cosine x, quantity squared. Now let's see if we can do some simplifying up top. I think I'm going to multiply through here to start. So I'll take this 3 cosine x, multiply it by 1, that gives me 3 cosine x, and then multiply it by the negative 2 cosine x, that gives me minus 6 cosine squared x. And then we have a 3 sine x times 2 sine x, so that's just 6 sine squared x, and that's all over 1 minus 2 cosine x quantity squared. Now whenever you see a cosine squared x and a sine squared x hanging out in the same area, you want to see if you can manipulate it so that you get cosine squared x plus sine squared x, because the Pythagorean identity tells us that cosine squared x plus sine squared x equals 1. And that's simpler. So we want to do that. So if I factor out a negative 6 here, I would get 3 cosine x minus 6 times cosine squared x plus sine squared x. But that is just 1. And negative 6 times 1 is just negative 6. So all of this just goes away. And then I have my 1 minus 2 cosine x quantity squared on the bottom. And I think that's as simple as I am going to make it in this case. So that is going to be our answer. So that's a little bit of work with applying the product rule and the quotient rule on some trigonometric functions. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.